Welcome again to the Ultimate Factoring series. This is lesson number 2, the difference of squares. If you haven't watched lesson number 1 on the greatest common factors, just keep in mind I'm going to assume you understand how to do that. So whether or not you've watched it is fine. Just make sure you know how to pull the greatest common factor out of terms before watching this video. So this is lesson number 2, the difference of squares. First of all, let's look at the rule for the difference of squares. If we have two numbers or two terms that are being squared, a squared minus b squared, then they will always factor with this same form, a plus b times a minus b. This works every time. So notice we're dealing with a binomial, bi like bicycle meaning 2. So two terms, a squared and b squared in this case. And difference implies that we are subtracting. So difference of squares. So when we are subtracting two terms that have been squared, they can always be factored into the original plus the original, and then times the original minus the original. So a squared minus b squared always can be factored to equal a plus b times a minus b. So let's talk a little bit more about the squares. It's called difference of squares. So I've listed here some perfect squares to make sure you know what to look for. So the first line is all numbers. Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So any number squared, these are called perfect squares. Another way to think about it is if you take the square root of any one of those numbers, it comes out nice and clean as a whole number. Okay, the second line shows you examples of perfect squares that are variables. So x squared is just x squared. X to the fourth is really just x squared squared. X to the sixth is really just x cubed squared. X to the eighth is really just x to the fourth squared, and you can see more examples on that line. Another way to think about it with the variables, since we're dealing with squares, that implies an exponent of 2. So any variable with an even exponent, any variable with an exponent divisible by 2 is a perfect square. Now the last line shows you that these can be combined. So sometimes you may have a number that's a perfect square like 4 combined with a variable that's a perfect square like x squared. Same with 16y to the fourth. Both the 16 and the y to the fourth are perfect squares, so that means they as a whole are also perfect squares, or a perfect square. Same with the final one there, 49x squared y to the sixth. Each of those individually is a perfect square, 49 x squared and y to the sixth. That means you can take the square root of all that and it all comes out very clean and even and whole. So these are the numbers you want to look out for in our perfect squares. So our first example is x squared minus 1. So it may be helpful for you to think about what's really being squared. This is really x squared minus 1 squared. So in this case, if you remember, we had a squared minus b squared equaling a plus b times a minus b. So in this case, my a is x and my b is 1. So I know my a and my b are x and 1. They're the numbers or the terms that have been squared. X is being squared and 1 is being squared. So that I can simply plug in x for the a's and 1 for the b's. And that's my answer. X plus 1 times x minus 1. If you prefer to put the x minus 1 first, that's fine. It doesn't matter since you're multiplying. You can do it in either order. You can write x plus 1 times x minus 1 or x minus 1 times x plus 1. It doesn't make any difference. Now these you can test or check by foiling. Now this is the correct answer, but you can also check by foiling. Remember, first terms, x times x, that's x squared. Outer terms, x times negative 1 is negative x. Inner terms, 1 times x is positive 1x. And then last, 1 times negative 1 is negative 1. So if you notice, these middle terms here just cancel each other out, leaving just x squared minus 1, which is exactly what we started with. So that confirms that our answer is correct. Next example is x squared minus 9. So again, it might be helpful to think about what is being squared. We really have x being squared minus, so think what squared gives you 9? Well, 3 squared makes 9. So if I'm going to follow the pattern that I had before, a squared minus b squared equals a plus b times a minus b. In this case, my a is x and my b is 3. So plugging in x where I see the a's and 3 where I see the b's, I arrive at my answer, x plus 3 times x minus 3. Again, if you want to check that answer, you can do so by foiling. Next example, y squared minus 25. Both of these are perfect squares. The exponent on y is even, it's divisible by 2, and 25 is a perfect square. We know that because it's the same as 5 squared. So we really have y being squared minus 5 being squared. So our a is y, our b is 5. So that gives us y plus 5 times y minus 5. Okay, amping up the difficulty a little bit, 4y squared minus 81. So in this first term, we need to think carefully. What is really being squared to make 4y squared? We need to consider both the number and the variable or the letter. So what squared makes 4? Well, that would be 2. And then obviously y is being squared. So what we really have is 2y being squared, because squared means times itself. So 2y times 2y would give me 4y squared. Then 81 is 9 squared. So this time my a is 2y and my b is 9. So I simply do a plus b times a minus b. Essentially, we're taking the square root of the first one plus the square root of the second one, and then the square root of the first one minus the square root of the second one. That would be another way to view this. Okay, last example for this lesson. We have 100x squared minus 49y to the fourth. So again, when you have coefficients, numbers with the variables, you need to consider both pieces as to what's being squared. Well, to make 100, you would have to use 10. To make x squared, you just have to use x. So it's really 10x that's being squared. Again, another way you can view this is what's the square root of 100x squared? Well, the square root of 100 is 10. Square root of x squared is x. And then we need to look at the 49 and the y squared. Well, the square root of 49 is 7. The square root of y to the fourth is y squared. So our first term is 10x. Our second term is 7y squared. So we do 10x plus 7y squared times 10x minus 7y squared. And that gives us our answer. One last thing to tell you before we end is these only work when you are subtracting. If you notice, every single example was subtraction in between. That's why it's called the difference of cubes. Difference of squares. It will not work if you're adding when it comes to squareds.